In our last lesson, we learned why the Department of Energy says over 95% of older homes have leaky ducts that are worth sealing, and that most duct systems have between 20 and 30% leakage, with some over 50%. You're probably wondering, how can ducts leak so much? And if it's so bad, why is our industry only now really getting serious about it? Today, we'll look at my top 10 reasons why. They will give you confidence that duct leakage is as bad as the authorities say it is, and also help you explain duct leakage to homeowners. Check it out. Reason number one why ducts leak so much is simply that air is invisible. You know it when you have plumbing leaks, but not when you have air leaks. I've joked for years that if heated air was pink and cooled air was light blue, air ducts would have been 100% sealed right from the start. But air isn't colored, and so the extent of duct leakage has been underappreciated, and sealing not thought to be so critical. Now granted, air leaks don't have the same immediate destructive consequences as water leaks. Duct leaks are actually more insidious, yet they have massive impacts on comfort, air quality, utility bills, and equipment durability, and sometimes even building durability, just like water. Reason 2. We can only see one crack at a time. So, air is invisible, but the actual cracks and gaps can be seen if you know where to look and you can get to them. The problem is that both we and our homeowners have a hard time grasping how one small gap here and a little crack over there could add up to very much. Until researchers invented duct test equipment, like duct blasters and the AeroSeal system, people just didn't know that the combined leakage was as great as it really is. Here's a very effective analogy. Duct leaks are like dimes. If you were walking down the sidewalk and saw a dime on the road, maybe a few feet out in traffic, you'd likely just walk on by. But if you saw 5 rolls of dimes worth $25 on the road, I bet you'd wait until there's a break in the traffic and then run out and grab them. Duct leaks are the same. One small gap may not be a big deal, but dozens or even hundreds of them, definitely worth sealing. Here's another version. A typical joint or connection averages, about 0.5% leakage. Doesn't sound like much? Not worth worrying about? Well, take a minute and draw out the typical duct system in your market. Then count up all the various duct connections, takeoffs, Ys, elbows, plenum seams, access panels, equipment connections, and boots. A low-end count is about 50 joints. Times that by 0.5% each equals 25% total leakage. A lot of sheet metal systems have over 100 joints. 100 times 0.5% is 50%. Obviously, this is an approximation. Individual leaks actually can vary probably from less than 0.1% to 2 or 3% of the total flow, and as much as 10% if a duct is disconnected. But it makes the point well if you keep it simple, at 0.5% average. I remember sharing this tip with a new salesperson in Florida at a class, and that night she explained duct leakage to a couple buying new equipment. After showing them a few pictures of their typical leaks, she did a rough sketch of their home's rooms and the flex duct system on a notepad. Together they counted up all the connections, they did the math, and she sold her very first AeroSeal. Legendary basketball coach John Wooden once said, "Little things make big things happen." Now that applies both to positive things, like the many sales tips you'll learn in this course. It also applies to negative things, like a whole basket of duct leaks. Reason 3 ducts leak so much is that duct leaks are under high mechanical pressure. The area of a gap or hole is only half the equation. How much air will actually pass through it is also a function of the pressure being applied. Were you aware that every time the big central circulating fan comes on, duct leaks are under about 30 times higher pressure than house leaks are? Forgetting this basic high pressure fact has contributed to many mistakenly thinking that little cracks didn't matter. Maybe they don't around windows and doors, but they sure do if they're in the ducts. Reason 4 is that we can't feel return leakage. Here's a little experiment for you to do. Put your hand about 6 inches from your face. Now blow on it. No problem feeling the air, right? That's a supply leak. Now let's go the other way. Hand 6 inches out and now suck air in. Can't feel it, right? Now try it with your hand an inch away like this. Still can't feel it, right? Well, I'm feeling a bit stupid trying to do this with you, but hey. Anyway, that's a return leak. The lesson. Our senses can easily detect a plume of air blowing at us, like supply duct leakage. But we can't detect air moving away, in this case, into a return leak. It's only going to move at high velocity right when it gets into the crack. So for a long time, while some effort might have been made to slap duct tape on supply leaks, also considering that was conditioned air, return leaks were ignored. What we didn't know was that return leaks can sometimes be even worse than supply leaks. A 10% return leak from a hot attic typically causes a 30% drop in capacity and efficiency of an air conditioning system. Reason 5 is sort of related to the last one about return leaks, and that is that some ducts aren't even ducts. Some of the most catastrophic leakage is found when the building cavities in the home are used for part or even all of the return air system. You look in the return grill and you see studs, sheetrock, floor joists, plywood, the underside of the stairs, or a concrete slab. Sometimes stud cavities are wide open up to the attic above, like we see in so many closet layouts where the furnace or air handler is an upflow on a plywood platform. Other times the wall cavity isn't wide open, but there's still lots of small gaps and wiring holes in the top plates right under the attic, like you see here, where AeroSeal has been used to seal the system. Sometimes the entire air handler closet is used as a return, perhaps with a louvered door or non-ducted grill, a pass-through grill through the wall. The entire closet is intentionally sucked on to pull return air back into the equipment. But air is stupid. It doesn't know it's all supposed to go through the grill. And so by mistake, outside air gets sucked in through every gap in the closet walls, floor, and ceiling. Building cavity returns are usually very, very leaky. Using building cavities to carry return air has now been banned in most new home building codes. Which raises reason 6, and that is building codes didn't require duct sealing. New home building codes have only just started requiring that ducts be properly sealed and tested right from the get-go. In the not too distant past, builders didn't have to get ducts sealed to pass. So they didn't. And in some states, they still don't. Or there may be a prescription in the code that says the duct should be taped or masticed, but testing isn't required. By the way, I encourage you to research the history and current status of new home duct sealing and testing in your state building codes. Also, find out if code was or is now actually enforced in the counties you work in. This will help ensure you go into newer homes with your eyes open and make appropriate recommendations. Lack of testing is our reason 7 because if you aren't testing, you are just guessing. If a post-seal duct leak test isn't done to confirm the problem was fixed and the ducts are airtight, neither the contractor nor the homeowner knows if the job was done right. So mediocre quality workmanship is the norm. Whether repairing an old duct system or installing a brand new one, even if the workers try real hard, they are missing that critical feedback loop from testing. It's astounding how many places duct systems can leak that most guys miss. Testing teaches. Before AeroSeal became widely available, for years, I taught contractors how to repair existing ducts by hand sealing using mastic. And you know one thing I found really interesting? Almost none of them stayed disciplined. They rarely did the best practice post-seal duct blaster test. Why not? Because they often didn't like what they discovered. Typical hand sealing old ducts struggles to get over a 60% reduction, and it's often barely 20% when much of the ductwork is hidden. Not that impressive to anyone, especially the buyer, so testing out gets avoided by companies doing hand sealing. Even systems that look like they were sealed at some point often still benefit from AeroSeal. In fact, I'd say usually benefit from AeroSeal. It routinely gets a 90 to 95% reduction, and AeroSeal has the before and after tests and certificate to prove it. Speaking of hand sealing, that's our reason number 8. Duct tape don't stick. When AeroSeal was invented back in the mid-1990s, Lawrence Berkeley Labs did accelerated aging testing on the new sealant and proved that it sticks and stays flexible for at least 40 years. Here's what scientist Max Sherman says about how well other products did.
So we looked at every product that was sold to seal ducts to see how well it worked. And pretty much all of them worked well if used as applied, except one product, and that product was duct tape.
So even if the ducts were taped, it is usually dried out and either failed or at least allows some leakage. Cloth-backed classic duct tape is the worst, but we've all seen foil tape fail too. It's just tough for any adhesive to last long term against the hundreds or thousands of times a year the ductwork expands and contracts as the system cycles. Gets hot, gets cold. Especially if denatured alcohol was not used to clean off the oils and dust first, which almost no one does. Now, duct mastic does work better than tape, but it is also often poorly applied. No cleaning first, not thick enough, fiberglass mesh tape not used, not applied everywhere it's needed. Reason number 9 applies only in certain markets. The misconception that ducts don't need sealing if they're inside the building envelope. Some companies would seal ducts if they were in attics or crawl spaces, but not if they were inside the thermal envelope, for example in basement-style homes. That's a very mistaken belief, for many reasons which we won't dive into today. Suffice it to say, it's a big reason in some parts of the country no duct sealing was ever done. The new home building codes are now changing to require sealing all ducts, no matter where they are located. Our last reason, number 10, is simply some guys did crappy work. No sugarcoating this one. Our industry has had some real craftsmen building the duct systems, and it's also had some brain-dead morons doing it. Many new home duct systems were unfortunately engineered and installed by the lowest paid worker of the lowest bid contractor that the builder could find. And it's up to us to help our customers finally get the performance from their duct system they deserve. Okay, so there's our top 10 reasons why ducts leak as badly as they do. The future is up to you to write your destiny by taking advantage of this great opportunity. And I am looking forward to helping you do that. Today's homeowners have a much greater expectation for a clean, safe, healthy, comfortable, affordable, and durable home. And fixing leaky ducts is almost always the best way to deliver it. As always, the audio track for this lesson is available for you to review as you drive around. And there's also a Windshield University audio file that just has some of the best communication nuggets on it, so you can practice those while talking to the windshield. Thanks for being an AeroSeal dealer. I'll see you on our next program.